Hello and welcome to another video on surds. Now in the previous video we discovered this rule about surds. So if we take the square root of a number and multiply it by the square root of another number, then that is exactly the same as if we take the square root of the product of those numbers. And just to make things a bit more tangible, let's go through an example. So for example, let's say we had the square root of 3 multiplied by the square root of 5. Well, that's exactly the same as if we take the square root of the product of 3 and 5. So 3 times 5, and we know that 3 times 5 is 15, so that is the square root of 15. Now, because these two things equal each other, we can go in the other direction. So let's say we were given the square root of 15. Well, we know that 15 is the same as 3 times 5. But then we can break this down into the square root of 3 multiplied by the square root of 5. So we can go in both directions. And that's going to be really powerful for this lesson and in your future mathematical endeavours, because it will allow you to simplify surds. Now, simplifying surds, it's not only a topic that I love doing, but it also comes up a lot in maths and is very useful. So it's good to get a lot of practice with this. So I'm going to go through a few examples of simplifying surds using this rule over here, and then you can have a go at doing some yourself. So we know this is a surd because it is not a perfect square. 18 is not a perfect square. If we were to write this as a number, it would be a decimal that goes on forever. So it is an irrational number. But we can simplify this. So if we think about this rule over here, we're going to go from right to left. So first of all, can we rewrite this 18 as the product of two numbers? Well, yes, we can. We can rewrite 18 as 9 times 2. So this is the same as the square root of 9 times 2. And now, instead of writing it like this, we can break it down into those two numbers. So we can break this down into the square root of 9 multiplied by the square root of 2. And now, notice this number here is not a surd. So the square root of 9 we can simplify. Okay, that is just 3. The square root of 9 is just 3. So we can rewrite this as 3 multiplied by the square root of 2. And now, this is almost done. We just need to tidy this up. Whenever we're writing things involving surds, we don't write it like this. So if we're doing 3 multiplied by a surd, we can just get rid of that multiplication symbol. Okay, because obviously as mathematicians we're quite lazy, so we don't need that multiplication symbol there. So this is just going to be 3 root 2. And this would be our final answer. Now you may be wondering why I chose 9 times 2. And the reason I chose 9 times 2 instead of 6 times 3 is because 9 is a perfect square. So my beast tip to you is to try and always choose a factor that is a perfect square. Okay, let's do another one. Let's say we wanted to simplify the square root of 28. So the first thing to do is find two numbers that multiply together to get 28, one of which is a perfect square. Now we could think about 14 times 2, but neither of those numbers are perfect squares. The other two factors of 28 are 7 and 4, and that would work because 4 is a perfect square. So we can break this down into the square root of 7 times 4. And then going one step further, we could break this down into the square root of 7 multiplied by the square root of 4. And now we can simplify because the square root of 7 we can't do anything with. We have to leave that like that. We can't break that down. But the square root of 4, well, that is a perfect square. So that is just going to be 2. So that's going to be the square root of 7 multiplied by 2. And we can just clean this up. If we write the whole number first, that's just going to be 2 root 7. Okay, I'm going to go through a few more examples, but please feel free to pause the video first and have a go at doing them yourself. So the next one I'm going to do is the square root of 50. So two numbers that multiply together to get 50, one of which is a square number. Well, we can't use 10 times 5 because neither of those are perfect squares. But I can use 25 times 2 because 25 is a perfect square. So if we split this up, this is going to be the square root of 25 multiplied by the square root of 2. And the square root of 25, well, that's just 5. So that's going to be 5 multiplied by the square root of 2, which is just 5 root 2. Okay, let's do a slightly tricky one. Let's do the square root of 32. Now, 32, what two numbers can we use? Well, we could use 4 times 8 because 4 is a perfect square, but we could also use 16 times 2. Both of these give us 32, and notice 4 is a square number and 16 is a square number, so which one of these options should I use? Now, an extension to my beast hint is to try and always use the biggest square number. So in this case, I'm going to use the 16 times 2. So I'm going to use this one here. So you can use this one and you would still eventually get the right answer, but you'd have to do another couple of steps first. And as a mathematician, you always want to use the method that results in the least amount of work possible. So let's carry on with this using 16 times 2. So it's going to be the square root of 16 multiplied by the square root of 2. And the square root of 16 is 4. So it's going to be 4 multiplied by the square root of 2. So we can just write this as 4 root 2. Okay, let's do one more. Let's do the square root of 27. So what two numbers multiply to get 27? Well, we can use 9 times 3, and I think that's the only option available to us. So this is going to be the square root of 9 times 3. And now we can break this down into the square root of 9 multiplied by the square root of 3. 9 is a perfect square, so the square root of 9 is 3, so that's going to be 3 multiplied by the square root of 3. And I've just noticed there's a lot of 3's in this question. So we can just write this now as 3 root 3. So just to recap the process of simplifying surds, we can use this rule that we established where we break a surd down into two different numbers. So the first step is always to identify a factor pair of the number, one of which is a square number. So if there's more than one option, so notice here we could have done 4 times 8 or 16 times 2, always choose the option with the biggest square number. And then once you've identified the factor pair, you can then break this surd down into two numbers. And then because one of them is a perfect square, we can actually simplify this one. And then once we've simplified it, then we just need to write it in surd form. Now there is a lot going on here, so I will do another video on this topic. Simplifying surds comes up an awful lot in maths, and there's a lot of overlap between surds and other topics. So it's really good to get a lot of practice with this, and partly because I enjoy doing this sort of work, so it's really a bit of selfishness from me, to be honest. So hopefully you'll see me in the next video where we can get a lot more practice with this and you will become surd masters. See you in the next video. Take care.